Yes.
Okay, everybody, let's take a look at 6-4, one triangle inequalities. All right, so let's take a look at what we have here. Excuse me. It says, from the base angle and exterior angle theorems, if one side of a triangle is longer than the second side, then the angle opposite the longer side is, take a wild guess. So what they're saying is, if you have a triangle, and let's say I know I have one side that's clearly bigger than the others. So let's say here's my longest side. What would I know about the angle across from that longest side? It's the biggest angle. So across from the biggest angle is the biggest side and vice versa. And across from the shortest side is the smallest angle. Okay, so the angle opposite the longer side is larger than the angle across from the shorter side. So I like to put in just plain English, so I'll sneak it in over here. Also known as across from biggest side, its biggest angle. Shortest side, shortest angle, smallest angle. And then, of course, we're going to have the middle side. Middle side is across from the middle angle. And then we can say the converse of that. If one angle of a triangle is larger than a second, then the side opposite the first angle is longer . Okay, so if we have one angle that I know is bigger than another, then I get to say that the side across from that big angle is bigger than the side across from the other angle. Okay, I'm going to draw you a picture. Oh no, my pen. My son does it all the time now. It's so funny. There you go. Yeah, I mean, you don't have to, but if you want to, you can. That's why I hate using the printed notes because I can't. I need to. I'm just drawing pictures, so if you want to, if you can sneak it in somewhere, feel free. If you can't. All right, so let me label my vertices here, A, B, and C. So let's just say I knew, let's do this. If I put in 100 here, I put in 50 here. And I said to you, okay, I want you to order the sides of this triangle from least to greatest. So first thing you would have to do in something like this, I would say, is find that third angle. Don't do anything until you know what all three angles are. So my third angle would have to be 30, of course. So, and remember, we always go off of the numbers, not how it looks. I would not be surprised if on a quiz or a test, we purposefully made a big angle, we put a small angle number in there. You can't go off of looks. Always look at the numbers. So I'm looking, I have 100, 30, and 50. So obviously the smallest one is 30. So that means that even though I don't know any of the measurements of the sides of this triangle, I know who the shortest side has to be. Which side is it? BC has to be the shortest side of this triangle because it's across from the smallest angle. So BC's got to come first. And then, so sometimes we write these as an inequality. So I know BC is the littlest. Who's got to come next? BA, AB, however you want to name that one. And then my largest would absolutely have to be AC. Okay. Easy enough. Now we can go the other way. I can give you the side lengths and not give you any of the angle measurements. And you can order the angles from least to greatest. So let's try that. I'm going to go to a second triangle. Sorry. Let's say I had 8, 9, 10. And I just asked you to order the angles from least to greatest. Who's got to be, oops, sorry. Which angle would have to be the smallest angle? Has to be C, right? Because this 8 is my shortest side and across from that is angle C. So again, when you're mixing angle symbols and inequalities, make sure it's, I don't know, I over exaggerate my inequality symbols so I don't like confuse them with each other. Who's in the middle? A. And then the biggest, of course, is B in this case. All right, easy peasy. Okay, okay. I know you think it is until I do this. All right, let's see. I'm going to give you some values here, and some I'm not. I feel sneeze coming on too. Thank you. Why does that work? That's so weird. So what I would like, I'm going to challenge you to this. I want you, in this diagram, there are 5 sides, 5 segments, right? Do you see 5 segments in this diagram? I want you to order all 5 from least to greatest. All sides, least to greatest. You can come up with this as a class. I would love one cohesive answer. I'll give you some time.
Least to greatest.
Yep, least to greatest, all five. Feel free to converse with each other. So you can come up with one answer.
C would be 50. Santa Claus would not.
Does anybody think they have it?
Is the longest side A, B? Oh wait, is B count as a side?
Yep. You have 5 total segments in this picture. I want you to order all 5 from least to greatest. Is it?
I don't have it written down, but wouldn't it go like AD, AD, BD, BC, and then DC?
That sounds interesting. I'm gonna write down what Aiden said, and then you can mull over if you agree. So you started with which one again? AD. Oh. AD. AB. So
Yeah, that's right.
there's what Aiden is proposing. See if you agree or disagree with that.
Oh, I get it. You took the 2 values and you add them together. And you find the average.
Angle C is the smallest of the second triangle. Angle A is BD is the greatest for the first triangle, and the smallest for the second triangle. Meaning the other 2 sides for the second triangle are bigger than the first.
If you have this and those like that's the difference between
So this is right. This is right. So let me, first of all, let's rewind. You all, I assume, found that missing third angle. Don't touch anything until you find that third angle. So I assume everybody did that. So these are 59s, correct? A 59 and a 59. Okay, so then maybe you're like, okay, cool, but now I can understand your confusion because you're like, all right, well, look, that's the 61 is the biggest angle, so BD has to be the biggest side. But 59 is the smallest angle, so this has to be the small side. That's true, but of each triangle. So let me give you a very helpful tip. Okay, anytime you have a question like this, wink, 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 just saying, what I might recommend you do is just look at one triangle at a time, okay? So I'm going to ignore, doesn't even matter which triangle, just pick one. I'm just gonna ignore this one. I'm gonna just pretend it's not even there. And one thing that you could do that's helpful, make up side lengths. It doesn't matter what they are. I'm just gonna make them up. I'm gonna make up values for the side lengths, okay? So if I have this triangle here, right? So let's add, but do like, I usually do somewhere like 8, 9, 10, like in that area. You don't want to do 1, 2, 3 because you're gonna get smaller and pick up fractions. So let's say, okay, the smallest side has to be AD. So let's just say that side is 7, right? Who cares? I'm just making up a number, it doesn't matter. 7, that means the one across from the 60 has to be bigger, so I'll call that one 8. The one across from the 61 has to be bigger still, so I'll call that one 9. Is that okay so far? I'm just making up these numbers, but now come over to this one. And now I see, oh, okay, so here's my shortest side, which is 9, which means this side has to be bigger than it. So I'll call this one 10, I'll call this one 11. Even if you had started with the other triangle, that's still gonna work. You would just have, so I would have started here, pick 3 random numbers, it doesn't matter. You come over here, and now I would just need to make them smaller than 9. But what Aiden said is exactly the key. It's because they share this one side. The biggest side here just happens to be the smallest side over here. But I have found that if you label do this, just picking arbitrary side lengths, now it's so easy when you step back. Now you can see, oh yeah, let me just put them in order. Now that I have them all labeled with some imaginary length that I made up. But I held true to the inequalities. I made sure that, okay, my first random number, I knew that the next number has to be bigger than that. You follow me? Okay, so helpful tip. You don't have to use it, but I find it's very helpful, especially when you have these things overlapping. So this would be our correct thing when we join them. All righty. Next up on our note sheet here, we have to recall the distance from a point to a line or plane is the perpendicular distance. It is the shortest distance. So remember, anytime I'm trying to measure the distance from a point to a line, we drop that perpendicular. So just if you want a visual of what I'm talking about, if I said, hey, how far is point A from this line? We would always just drop a perpendicular from that point. That's what we are referring to when we're talking about the distance from a point to a line or a plane, whatever it is, we drop perpendicular, that's our distance. Okay. Triangle inequality. This is so cool. Let me ask you this question. Could you take any 3 side lengths you wanted and create a triangle out of them end to end? Think about it. If you went into the woods and you picked up 3 sticks, any lengths you wanted, and you connected them end to end, are you guaranteed to make a triangle? I'm hearing some no's. For good reason. Take a look at this. Say these were 2 of my sides. Okay, and I have 2 sides of my triangle. I want to make the 3rd side of the triangle but this is the stick that I chose. And I want to try and connect these things end to end. I'm going to run into a problem. Because no matter how far I stretch these, it's never going to reach. Right? There's this point where it's just the third side is just too big. It's not going to work here. So I can't make triangles out of any three values that I want. So the question is, well, what can you do? What could you do? So why don't we try this? I'm going to give you some lists of sides. So that would let me know if I have a right triangle or not. I just want to create any possible triangle. So let me give you some lengths and I'll tell you if it works or doesn't work and see if you can come up with a rule. Okay, so how do I want to phrase this? Do these side lengths, our fancy word for this is determine or create, make up a triangle. So that's the question we're trying to ask here before we fill in the blank of the triangle inequality phrase here. All right, so let me give you some. 6, 7, 8. If I had 3 sticks and one was 6 inches, 7 inches, 8 inches, yes, I could create a triangle out of that. If I had, how about 5, 5, 5? Should I make a triangle out of those?
Yes.
Of course I could. That's an equilateral triangle, so that's a yes. If I had a 1, 2, 3, what do you think? It's a no. If I had a 2, 2, 3, that's a yes. If I had a 4, 5, 10, that's a no. So take a moment, see if you can think and reason your way through. Oh, Sam, you got something?
Some of the two smallest sides has to be greater than the large side.
Oh, you're spot on. Take a look at my two. If these are my two shortest sides, right? If let's just say this is 1 and this is 2 for the sake of easy numbers, right? If this is 1 length and this is 2 lengths. If I tried to connect that with a length of 3, wouldn't I literally have to like put these perfectly flat? I can't make a triangle out of that. So that's why this one didn't work, the 1, 2, 3. If I add 1 and 2 together, I'm only just getting to 3. I can't make a triangle. I can just make a straight line, right? They would just equal each other. So that doesn't work. But if I had 2 2s, like a ballerina, right? If I had 2 2s, I could add that with it because I have enough, right? If I had, let me see, do I have one that's actually 3 units? Oh yeah, the green one. The green one is 3 units long, and as you can see, I can actually connect them. I have extra, right? So my two shortest sides, when I add them together, they have to be bigger than the third side. Does that make sense? Okay. So the sum of so we're going to stick in here greater than the third side. Okay, so let's try this another way. I'm going to give you 2 side lengths, and I wanted you to tell me what the range of possible values is for the third side. So what could the third side be? What range could it be? And so let me stick this right here. Given side lengths of, oh, I don't know. Let's pick, how about 8 and 10? What is the range of possible values for the third side. Let me have this list there. So think on that for a minute. You know,
It would be like parentheses 2, comma, 10, bracket, then union. And it would be like parentheses 18, positive infinity. Because there's like a zone of numbers that can't be true.
yes, you're absolutely right. Well, hold on. You said, what were your numbers?
Like parentheses means it can't be there.
Right, you wouldn't include
So-
that value itself. And
It
it was,
would be 2, comma, 10 with a parentheses in front of the 2 bracket. Right?
so you're saying anything between 2 and 10, and then jump up to 18 and bigger?
Oh, it can't be 18.
So you're saying that the third, an example of the
Oh,
third side
the
that you,
third side. It would just be greater than 18.
so if you had a third side of 20, let's say, would that work?
Yeah. No. Oh,
No.
same stuff.
You're right, 18 is important. Yep. Less than or equal to 17. So, what about 2? Could you have 2, 8, and 10? No. Right? Because 2 plus 8 gets me to 10. And that's a problem. I can't have them being equal. Because remember, if I add the 2 shortest sides, it's got to be greater than the third. Can't be equal. Julia? From 3 to 17? So what if I had like 2.5? Right? 2.5 plus 8 is bigger than 10. You're like right there, Patrick.
Greater than 2 but less than 18.
That's it. Greater than 2, less than 18. So here's how we're gonna write it. Oh, I'm sorry, the sun's like messing with me again. Works. Okay, cool. Thanks, son. Hold on, let me put up my, where's my fancy folder? Okay, good. So it's got to be something that is greater than 10, yet less than 18 at the same time. So where X is the third side. Okay, does everybody know where these numbers are coming from? Basically, to get your smallest number, you're just gonna subtract the 2, right? My original sides were 8 and 10. So if I just subtract them, I get a 2. If I add them, I get an 18. So that third side has to be somewhere in this window. Something bigger than 2, yet it has to be less than 18 at the same time. I can't go too small, and I can't go too big. Does that make sense? Okay. So what if, I'm going to give you another one. What if the sides were, so example 2, side length of 4 and 4. So if you have 2 sides of a triangle so far that are 4 and 4, what's the range of possible values for the third side? That was short-lived. Oh, it still looks okay. 4 and 4. Julia, go ahead. You got it. Greater than 0, less than 8. But you can't have a side length of a triangle that's 0, right? We don't. We have something greater than 0. And if you think about what this looks like, right? So here's my 2 4s, 4 and 4. Couldn't I, let me zoom out a bit. I know it's an isosceles triangle, right? So all I need to make a triangle is literally any third side that's something bigger than 0 to create this triangle, right? Anything bigger than 0, and I get, it might be a really narrow triangle, but I can get there. But I can't go so big because straight across gets me to 8. So it's got to be something less than 8, otherwise it's going to be too big. Does that make sense? So even though it's isosceles, it doesn't matter. It still works the same way. Something bigger than 0, because I can make a teeny tiny little triangle, but I can't be so big that I'm fully stretched out and I just can't reach at the end. Oh, I love these triangles. Who knew, right? So much information packed into one tiny little shape. And there you have it. Any questions about the triangle, inequality, any of this stuff? No? Okay, so let me give you your assignment for today. You got plenty of time to get started. Let's see here. Yeah, that's the one I want. Just check this. I'm not sure which of these two I want to do. 2, 2, 2. Yeah, okay. All right, so here is your assignment for today. So if you look in these, I don't know if you've ever noticed, but they say on the side, like there's a section A, a section B, and a section C. So if you look on the left, you'll see a little blue A, B, or C. So in the A section, I just want you to do the multiples of 3. In the B section, try the odds. And then just numbers 20 and 21. They're going to say, so 20 says, discover, say, and prove a theorem. You're not going to like do a 2-column proof or anything. Just figure out how it is, the statement that they're making. How is that true? Okay, give it your best shot. Ask me questions if you're stuck. If you want to work together, feel free. All right, let me. Sure, just give me your phone. Thank you.